So the factor theorem connects the zero of a polynomial. What the zero of a polynomial is a number that when you put it in for x, the polynomial becomes zero. It's a value of x that makes the polynomial zero. The factor theorem connects the zero of a polynomial with a factor of the polynomial. And I'm going to explain the factor theorem in a slightly different way here, but if something is a factor, if, for example, x minus a is a factor of a polynomial, then that means if you were to divide that polynomial by that factor, you would not get a remainder. And the day before yesterday, we learned that the remainder is found by putting the zero of the binomial into the polynomial to get the remainder. But if x minus a is a factor, the remainder has to be zero, which means p of a has to be zero. You know, there's another real simple way to understand why this statement is true. And it's that if you have a polynomial and x minus a is a factor among other factors, then when you write that polynomial in factored form, one of those factors will be x minus a. And if you were to put a in for x, this first factor would become a minus a, which is 0. And since it's multiplied by all the other factors, you would get 0 for the polynomial. Anyway, that's the factor theorem. So for example, if you know that the zero of a polynomial is -2, then you know a factor of the polynomial is x plus 2. So if you can, I don't want to say stumble around, but use your calculator to find a zero of the polynomial, then you've determined a factor, and you can use synthetic division to factor it further. If a zero of a polynomial is 3, then the corresponding factor is x minus 3. Now there is something else I want to show you here that wasn't in your notes yesterday, but we're going to have to deal with it, and we will encounter it. What if 0 is a 0? Just stop and think about what that means. If 0, the number 0 is a 0 of the polynomial, that means when I put 0 in for x, I get nothing. The only way that can happen, is if your polynomial is something like, I don't know, 3x to the 4 plus 12x squared minus 32x. There cannot be a constant term. Because if there's a constant term in a polynomial, when you put 0 in for x, everything will turn to 0 except for that constant term, and you can't get 0. So the only way 0 can be a 0 is if the constant term doesn't exist. And what that means, if you take a look at this polynomial I've written, there's a factor of x, isn't there? A common factor of x. And that's the third case. So we have a case where we have a -0. We have a case where we have a positive 0. And what if the 0 is itself 0? Then the factor is x. So you're going to have to get used to that. All that being said, does anybody have any questions? Let's start, please, just with the textbook. Does anybody have any questions you would like me to explain from the textbook? Go ahead, Ian. So this is where we're going to set up a system of equations. If they're both divisible by x minus 2, that means for each of these p of 2 will be equal to 0. So your first equation is going to be 2 times 2 cubed plus m times 2 squared plus n times 2 minus 3 equals 0. So all I've done here is I've taken this polynomial expression and I've replaced the x with 2, and I'm just double checking to make sure I've transcribed it correctly. I'm going to clean it up right now. 2 cubed is 8 times 2 is 16. 16 minus 3 is 13. So I end up with 13 plus 4m plus 2n equals 0. And I suppose we could move that 13 over, but it doesn't matter. We can leave it where it is. Does that look okay, everyone? I'm asking not just to get you to check my work, but to make sure you're following along. When I use p of 2 equals 0 for the other function or the other expression or the other polynomial, whatever you would like to call it, I'm going to have 2 cubed minus 3 times m times 2 squared plus 2 times n times 2 plus 4 equals 0. So what I'm looking at there is this equation, or this function rather. I'll double check my entries, but I think they're fine. I'm going to simplify this one. 2 squared is 4 times negative 3 is negative 12, so I get negative 12m. I have plus 4n. This is going to be equal to 0. And for numbers, I have 8 plus 4. I believe I get this. So I'm dealing now with these two equations. I'm dealing with this equation and this equation. There's so many things you could do here to proceed. Personally, I would probably, I'm going to do two things at once here. I'm going to take this second equation and I'm going to divide it by 2. And I'm also going to change the signs on everything. I'm going to multiply everything by negative 1. Or if you like, I'm dividing by negative 2. And if I divide by negative 2, this is my motivation. When I divide this 4n by negative 2, it becomes negative 2n. And if dividing by the negative is worrisome for you, then divide everything by 2 and then switch the signs. Multiply by negative 1. And my motivation is that now, in this second equation, I have negative 2n, but in the top equation, I have positive 2n. And if I were to add those two equations at this point in time, the n's would go away. I can see I've made maybe a rookie mistake here in terms of teaching. I'm going to divide everything by 2 first. I think it's a mistake because I could tell by the looks on some of your faces I lost you with doing two things at once, and that's fine. So I've divided both sides of this equation by 2 so that the number of n's in each equation is the same. Then, because I like to add equations instead of subtracting, I'm going to multiply everything by negative 1. So this is my second equation. Let me rewrite my first equation. This was equation 2. This is equation 1. Let me rewrite my first equation as 13 plus 4m plus 2n equals 0. And now you can see that when you add those two equations, the n's will go away. When I add them, I get 7 plus 10m equals 0. So 10m equals negative 7. Again, just two things. If you see this kind of question on an exam, and you are likely to see it on an exam, the parameters when you solve for them are more likely to be simple fractions or integers. But is the answer for m in this question negative 7/10? Okay. I won't finish the question other than to say that once you determine m is negative 7/10, you can take this number here and put it in. Well, there's lots of places you could put it in. You could put it in here and solve for this variable. Yes?
How come my problem was I kept trying to make the two equations equal each other because I knew that they both equaled 0. So if I
because then you end up with another equation with two variables.
Don't you just put one variable on the other side? Oh wait, then it's not x and y, it's two x variables. Or x filtered. Sorry, never mind, that doesn't make sense. I understand now.
Okay. Other questions? Yeah, Arden.
If the polynomial has multiple zeros, which one should we use?
To factor the polynomial completely, any one you want. So what Arden is saying, I believe, is that let's say you have a polynomial and it turns out, this is written in this form. And it turns out that when you factor it, you have three factors. And by the way, two of these factors, I don't want to use a here because I've already used a up top. Well, let's use numbers. Let's say two of these factors were x minus 3 and x plus 8. And the other factor would have to be, since this is probably not 1, it would have to be something like 2x whatever plus 5. I'm just making things up here. I believe what Arden is saying is if you were asked to factor this polynomial and you use your calculator or your wits or your math skills to find out that one of the zeros is 3, x equals 3 is a 0. But maybe the person beside him determines that x equals negative 8 is a 0. Or I guess in the case of Arden's question, he's determined they're both zeros. Which one should he use with synthetic division first? And the answer is it doesn't matter. If you do synthetic division of the polynomial by x minus 3 and then factor the result will contain the factor of x plus 8. If you use synthetic division to divide the polynomial by x plus 8, then you'll be left with a quadratic, which when you factor will contain a factor of x minus 3. So the order doesn't matter. If I had the choice here, I would probably do the synthetic division with this one because 3 is a smaller number. So I'm likely to get smaller results in my synthetic division. Does that answer your question? Does anybody have any other questions you would like me to go over? Ian?
Number 6.
Yeah. So if negative 5x is a factor, well, this goes back to the original thing I said over here. That if x is a factor, then 0 is a 0. Okay? If you're being told that negative 5x is a factor, there's no difference between saying negative 5x is a factor and x is a factor. Because if I'm saying negative 5x is a factor, that means the polynomial contains a factor of negative 5x. And it contains other factors, right? And by the way, I pondered saying this earlier when I used the same analogy. There's nothing here, right? So the remainder is 0, which means all of those things are factors. But if negative 5x is a factor, you can see that when I put 0 in here, this thing will be 0. Because 0 is a 0 of negative 5x. I think it's important you understand, everybody, what I mean when I say 0 is a 0 of negative 5x. I mean that this 0 that goes into negative 5x produces an output of negative 5x of 0. So this that I'm pointing at is a 0 of this because it creates 0 in the polynomial. And what that means is that p of 0 has to be 0. Because if I change x to 0, if I say, what is p of 0? I'm saying you're putting 0 in for x everywhere. But as soon as you put 0 in for x here, you're done. The whole thing is 0. It doesn't matter what anything else is. This is very similar, everybody, to me asking you from Math 20, what are the solutions to this equation? It's a quadratic equation that in Math 20 maybe you've factored to get it into this form. We just look at it and say x equals 2. Am I right? Well, why do we say x equals 2? We get caught in autopilot mode and we forget the reason why x equals 2 is because 2 is a 0 of this. Why is 2 a 0 of that? Because when I put in 2, I get 0. And since that thing, x minus 2, is a factor, that 0 we get multiplied by the other factor is 0. The difference here is we're just adding on other factors, right? So what value of x makes this 0? -3. What value of x makes this one 0? 2. What value of x makes the x plus 1 0? X equals -1. What value of x makes 3x 0? 0. So these are all zeros. I know this gets repetitive, but they're all zeros of the individual factors. But given the nature that factors multiply to give the whole thing, they're zeros of the whole thing. Any other questions before we get started today? Yeah, go ahead. 8? So I guess what we have to do here is take the statement that says this is divisible by x minus 3, translate it to a useful statement that we can use to find the missing parameter k, and then factor the resulting polynomial to see what we get. Like, if you knew the value of k here, Marcel, and the question just said, which of the following is a factor of the polynomial, you would factor it. The problem is we don't know the value of k. So I'm going to put 3 in for x, and I'll have 3 times 3 cubed minus 9 times 3 squared plus k times 3 plus 12. This has to equal 0. I'm just pausing to double check to see my substitution is correct. I believe it is. We have a whole bunch of numbers we have to put together. And I believe that these two numbers are equal, but opposite. They're both 81. So we end up with 81 minus 81 plus 12, which is 12. I move it over. And what I've determined now, Marcel, is that k is equal to -4. Now this is actually a pretty tricky question because of a number of things. One, none of these factors in our choices fit this mold, do they? Because of that coefficient of 3 and everything. And the other thing is, some of these supposed factors are actually quadratic factors. C and D are quadratic factors. And maybe when you do synthetic division, that's what you're left with. There's nothing to say you can't be left with that. But now that we know that the polynomial is Now that we know that the polynomial is 3x cubed minus 9x squared minus 4x plus 12, we can do synthetic division of that polynomial. I mean, at least we know one of the factors already, right? X minus 3. So we don't have to go hunting for it. Let's see what we get when we do the synthetic division. I bring the 3 down, multiply, I get 9. Oh, add, I get 0. I'm not getting any term there. Multiply, I get 0. Add, I get -4. Multiply, I get -12. Add, I get 0, which is a check. So the quotient is this, which means the polynomial in factored form is the x minus 3 times that thing, which is 3x squared minus 4. and 3x squared minus 4 isn't factorable. So this is, further evidence of what I said earlier, that you don't have to have everything that's factorable completely. Does that answer it? Okay. Your polynomial doesn't have to be factorable into as many factors as the degree. And this is going to kind of connect to the fact that we said a degree 3 polynomial could have 1, 2, or 3x intercepts depending on the nature of things. And we would have to look at those factors. Anyway, we are going to move on now. If you do have further questions, then we can certainly talk about them later. This is on page 16 of your unit handout. What we're going to do is look at the relationship between linear factors of a polynomial and zeros of the corresponding function. And I kind of really have touched on this already in the conversation that was initiated by Ian's question about having a factor of negative 5x. Out of that came this idea. The zeros of the polynomial must be equal to the zeros of all of the factors. Right? So we know what that relationship is. And we're going to solve at least one word problem here dealing with polynomial functions. So to begin with, as a quick review here, let's factor this expression. So because it's degree 4, we're going to have to determine a zero, use that zero to identify a factor, perform synthetic division with that factor to get a degree 3 factor, which we will repeat the process using. Our potential zeros here are any numbers that are factors of 40, factors of negative 40. So, x equals plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 8, plus or minus 20, plus or minus 40. I maybe even missed one there. I don't think we need to write them all down. These numbers must be factors of 40. Or, to be specific, factors of negative 40. Because those zeros would be a constant term of the factor, the product of all the constant terms has to give you negative 40, so those constant terms have to be factors of negative 40. The most efficient way to do this, whether you're doing a written response or multiple choice, it doesn't matter, is for you to load into your calculator for y1 the polynomial expression. I have 2x to the 4 minus 15x cubed plus 29x squared plus 6x minus 40. And this is the way I do it. I have my own reasons. If you find it convenient to do it that way, that's fine. And if anybody ever says to you, why are you doing that? Say, well, it doesn't matter. It's just the way I do it. It's the same thing. Double check everything very carefully because you don't want to walk away from this and look in your tables if you haven't got it entered correctly. But I think I'm okay. Set up your table to be on ask. Go here. I happen to have a couple of numbers loaded from last time, right? Now this is really nice because, well, I'll come back to it, but basically I've already identified two factors, haven't I? And they're different. So when I do synthetic division the first time, say with x plus 1, then I don't have to go back to my calculator and re-enter anything. I can just do synthetic division with x minus 2. So let's do that. Let's go with this statement that p of negative 1 equals 0. That tells us that x plus 1 is a factor. So we are going to do synthetic division of that polynomial by x plus 1. Two, negative 15, 29, 6, and negative 40. I maybe, just a note here, if you look at what I've written, I maybe wrote the numbers too close together. Just from a working standpoint, when you're working on paper, don't be afraid to spread things out. I better double check that as well. 2, negative 15, 29, 2, negative 15, 29, 6, and 40. I'll just spread this out a little bit. And I'm dividing by x plus 1, so the 0 is negative 1, and I'm off and running. 2 multiplied by negative 1 is negative 2, add is negative 17, which again, I kind of talked a little bit about this yesterday. That starts to worry me a little bit, the number negative 17, how that's going to clean itself up. I multiply, I get 17, add 48. Thank you. 46. Multiply negative 46. Oh, there we go. I'm starting to feel a little relief because when I add that, I get negative 40. Multiplied by negative 1 is 40. Of course, this is your remainder, which makes sense. We have also determined, looking at the calculator, that 2 is a 0, which means x minus 2 is a factor. So I can certainly feel free to continue with my synthetic division here of the result of the first division by dividing the result of the first division by x minus 2. It was p of 2 equals 0, wasn't it? Okay. So I'm just going to continue here. I put the 0 here. Multiply, I get 4. Add, I get negative 13. Multiply, I get negative 26. Add, I get 20. Multiply, I get 40. Add, I get 0, which of course is the remainder. The remainder is 0 because I'm dividing by factors. So we have discovered that the original polynomial contains a factor of x plus 1, contains a factor of x minus 2, and after, the word I use is extracting. After extracting the first factor, we got that polynomial. After extracting the second factor, we got this polynomial. So that's the third factor. 2x squared minus 13x plus 20. And we don't know for sure whether that's factorable. We saw an example today, I think it was Marcel that asked the question, where we got a quadratic that wasn't factorable. This might not be factorable, but I believe it is. Okay, it is factorable because I don't want to give that to you at this point in the unit. So the polynomial, we could rewrite the whole polynomial in expanded form, but I'm not going to. Contains a factor of x plus 1, x minus 2. Let me talk briefly about some tips in factoring here. I know that if this is factorable, and I'm going to assume it is, that the first term in each of the two factors to give us this quadratic have to multiply to give 2x squared, and they have to each contain an x. So there's only one option, just to put 2x and x. The two numbers that I'm going to put in this place have to multiply to give 20. They have to both be negative because I've got negative x's in my quadratic. But I mentioned this before, I don't know about in this class, but if you've had me as a teacher, you know, could it be 1 and 20? Maybe. Could it be 2 and 10? Maybe. It's more likely to be numbers like 4 and 5 that are closer together. Okay? Now, I'm not going to put the 4 here, because if I put a 4 there, I will have created a common factor of 2, which I could factor out and put at the very beginning of this. But the original polynomial doesn't have a common factor of 2. So this would not be a y. Well, it would be a waste of my time to try putting the 4 there. And I put the 5 here. And I FOIL things out and see that I get negative 13x. Again, we talked about this a little bit yesterday. If you want to use decomposition, use decomposition. What I want you to do is factor it in the quickest manner possible. There's no work that needs to be shown at this level for factoring. And that's it. We're done. That was just a review of what we already knew how to do, so let's move on and take a look at B. Let's graph that polynomial function. Given that I've already got it entered in for y1, this is going to be easy. However, we're going to have to contend with window settings here that might be confusing. Why is this? When you look at 2x to the 4, as soon as I get to a number like x equals 8, 2x to the 4 is going to be a really, really big number. 8 to the 4 is huge. So if I go zoom 6, which is what you've kind of been taught to do, I'm likely to see very steep lines. And there's a couple of ways that we can adjust the window settings to make those lines less steep. One of them is to understand that all of this region here and all of this region here is not needed. The graph doesn't exist there. So in my window settings, why don't I go from about -3 to about +6? And what that's going to do is that's going to stretch out that graph. Let's start with that. So I go window, -3 to 6. Let's take a look at it now. Well, it's better, right? I mean, it has some curviness to it as opposed to just a bunch of almost vertical lines. The only other thing, and by the way, this takes us back to the first lesson of this unit, you should know since this is degree 4, both arms are up, because the leading coefficient is positive as well. So there is some lowest point down here. Where we are at now is we kind of have an idea that this must go down. So rather than going from -10 to 10 for y, which is what zoom standard does, let's change the minimum y to something like -50 or -100. And it's just a number. We can play around with it and change it later if we don't like the result. I'm going to go negative. I mean, I already know the y-intercept is -40, right? I got to go down to at least there, I would think. I'm going to go down to -120. And that may be overkill, but we'll find out. And I changed the wrong thing. I think I changed x, didn't I? I got to wait it out. We had x at -3. I want y to be -120. Well, that's good. So -120 was too much. Let's go -50. And what we are asked to do is find the x-intercepts. So I'll remind you how to find the x-intercepts here. You go to calculate, your calculate menu, and you choose 0. That's an interesting thing that we're choosing. We're choosing to find a 0 of the polynomial, which is an x-intercept. We hit enter. We put our cursor to the left of an x-intercept. So I'm going to go with the x-intercept on the left-hand side of the screen. I need to scroll so my cursor is to the left of it, and I hit enter. Then I scroll so my cursor is to the right of it, and I hit enter, and I hit enter. And we get an x-intercept of -1. I hope you see where this is going. If the x-intercept is -1, then a 0 of the polynomial is -1, and one of the factors is x plus 1. If we repeat the process for the one on the right, and by the way, you don't have to scroll. When it says left boundary, I hope you see it's 4, right? Let's say you're not sure if it's 4. For left boundary, you can just type in 3.7 and it will put it there. And then we can scroll, or you can put for the right boundary 4.3. Anyway, we end up with x equals 4. And again, I hope you see where this is going. Since 4 is an x-intercept of the graph, 4 is a 0 of the polynomial, and if 4 is a 0, there must be a factor with a 0 of 4, which means x minus 4 is 0. Now, how do we contend with this little bump here, this little part here? Let's imagine you didn't know there were two other factors. You want to zoom in on that. By the way, never go zoom in. Zoom in is just a nightmare. Same with zoom out. In this case, choose zoom box. How many of you have used zoom box before? If you look at what happens here, you go zoom box, and there's a little cursor. You can't really see it, but I'm going to move it. There it is. And what I'm going to do is move that cursor to a place where I want the bottom right of the new screen to be. So I'm putting the cursor here, and I hit enter, and then I scroll, and I can stretch out. It's like a little square or rectangular piece of elastic. I stretch this out, and you can start in whatever corner you want. And when I hit enter the second time, my calculator is going to take that and zoom in on it. And now I can use my calculator to find those x-intercepts. I'm curious, before we do that, by a show of hands, or by a nod of the head, or a thumbs up, how many of you see that we could have found this factor, and this factor by looking at our table? But we can't find this factor easily by looking at the table. With me on that? I'll make a note to you that this type of factor, which is not an x minus a factor, would appear at most 2 times in a polynomial. You would never have more than 2 of them. All right, so let's go back to our calculator. And I'm going to find the intercept on the left. I mean, I think you see where this is going to go. I think it's going to be 2, but yeah. These are called, everybody, integral zeros because they're integers. Let's find the other one. How many of you know what the other one is by looking at this factor of 2x minus 5? Should be 5 over 2, right? If you don't see that, I'll explain it in a second. So we'll do the same thing. 0. And you get 2.5. Now, you see where it says x equals 2.5? I just want to teach you about your calculator a little bit. It says x equals 2.5. If I quit out of here and I hit the x key from the home screen, it has that value stored in there. And I think that everybody at this level should be able to write that as a fraction, but I'm going to use the math key to show what it is. So the x-intercepts in answer to this question, the x-intercepts are -1, 2, 4, and 2.5. -1, 2, 4, and 5/2. Correct? What is significant about them? This is the 0 of the factor of x plus 1. This is the 0 of the factor of x minus 2. This is the 0 of the factor of x minus 4, and this is the 0 of the factor of 2x minus 5. why is 2x minus 5 going to give you that as a 0? And I don't want to belabor this too much longer because we have a few more questions to do, but how many of you look at the x minus 2 and your brain just says, oh, the 0 is 2? You don't do any work, do you? But what the reason is for the 0 being 2 is because you take that factor and you set it equal to 0 and you solve that little equation. You add 2 to both sides and you get 2. Well, if I take 2x minus 5 and set it equal to 0, then I move the 5 over and I divide by 2. So the 0 of that factor is 5 over 2. What am I saying? In the end, what I'm saying is, you didn't have to do all this to factor that polynomial. You could have found all the factors by looking at the x-intercepts in conjunction with your table. And I want to show you one last thing here with this question before we move on. If I asked you to factor that polynomial and you wanted to use your calculator, do you agree that you could identify from your table that one of the factors is x plus 1? Was it x plus 1? Okay. That you could go to your table and start putting in different numbers that are factors of the constant term and get that. And you could figure out from your table that one of the factors is x minus 2 and one of the factors is x minus 4. But you would be unable to easily from your table find out the remaining factor because it's that 2x minus 5. You should still be able to figure this out because this times this times this times this has to give you 2x to the 4. It's got to be 2x. This times this times this times this has to give you negative 40. Well, 1 times negative 2 times negative 4 is 8. I guess we need a negative 5 here. So it's kind of an interesting way to cheat. The only thing, of course, is if you have two factors like this one, that's not going to work. You're going to have to find some other way to do it. All right, any questions with example 1? C, explain the results. I already have. I don't think we really need to write anything here. As long as you know that the x-intercepts of the function are the zeros of the function, which means they're the zeros of all of the factors, then you understand what's going on here. So this question says factor this polynomial. Imagine you have a multiple choice question on a quiz in Monday's seminar that says, what is this in factored form? Well, we could stumble around and do everything we learned yesterday, or we could graph it, and in conjunction with the graph and the table, determine the x-intercepts, or the zeros. And I hope you understand, when I say x-intercepts of the graph, that's zeros of the polynomial, right? They're the same thing. So I'm going to go to my table. What kind of numbers am I going to try? I'm going to try numbers that are factors of 12. Well, I already have that. And by the way, now let's do this. Let's not go ask. Let's go automatic. Let's set up our table to be on automatic. And as long as this number is 1, as long as your delta table, that's what that weird shape is, as long as your delta table is 1, it's going to create a table that goes up by 1 each time for x. So when I go to my table, did I not hit enter? When you go to your table and you're on automatic, you have a list of numbers, don't you? My calculator just crashed for some reason. Let me restart it. Oh, that's really weird. There we go. So scroll up, scroll down. Oh, we already have 2. Look at that. -1 is a 0 and 3 is a 0. So we're done. You know what? We don't need the graph here. Let me show you why we're done. Because I know that x plus 1 is a factor. I know that x minus 3 is a factor. I know that it's degree 3. It's a degree 3 polynomial, which means it can only have one more factor. And that factor has to be 3x plus 4. Because all of the x's multiplied together have to give you 3x cubed. All of the constants multiplied together have to give you negative 12. By the way, not to downplay the whole x-intercept thing, if I take a look at the graph and I determine this x-intercept, it will be 3. I'm going to zoom in on this. Using zoom box. And if I determine, well, I guess I'm going to have to determine them. I can't remember which. I believe if I determine this x-intercept, it will be negative 1. Okay? Let me show you what happens when I determine the next one. Enter, go to the right, enter, enter. It's negative 4/3. I can quit out of here, pull up x, tell my calculator to put it into a fraction. It's negative 4/3. So, not everybody gets this. It's not easy for everybody. How do I turn that into a factor that's equal to 0? Well, I multiply both sides by 3. And then I add 4 to both sides. So the other factor is 3x plus 4. But that's how we factor them. Let's not do this one. Are you okay with that? I guarantee you that 3 of the factors will be factors of the form x minus a, so you could find out what they are by looking at your tables. You will not be able to cheat and just figure out what the last couple of factors are, because I think they're both going to be not x minus a factors. They're going to be 2x plus 5 or 3x minus 8 or something. So you would have to use the x-intercept method. If you want, you can try it a little bit later, but you're going to have other problems you can try as well. Let's take a look at, this is the last example, I believe. Yes? Okay. We're going to make a box here by taking a piece of material. This is metal. I'm not using metal. I'll show you what I mean in a second. And it's 10 centimeters by 20 centimeters to begin with before I do anything with it. And I realize that this is not 10 centimeters by 20. It's not even the right ratio, I don't think. No. But I want you to understand, because this often pops up on exams and diploma exams, what we're going to do here. We're going to cut out a square from each corner. So this is going to be discarded. And then we're going to fold up those flaps we create to make a box. So the bottom of this box is this. This is the bottom of the box. This gets folded up, this gets folded up, this gets folded up, and this gets folded up. And we get a little box. It's an open box. So for example, if I take that sheet of paper and I cut out squares that are this big from each corner, then I can fold this up and I can take a piece of tape and tape it here and tape it there, and I get this box. If I was really smart, and I don't know why textbooks don't do this, I wouldn't cut it out. What I would do is just cut it here so that when I fold it up, I have a flap that I could glue or tape on there. But textbooks always say, oh, you cut out the square. It's not very smart. Anyway, I got a box. And the box has a certain volume to it. If I made this airtight and I filled it with sand or I filled it with water, there's a certain volume, cubic centimeters it could hold. If you decide that you want more volume, then you might say, well, you know what? I'm going to cut out bigger squares. I'm going to cut out these squares. I hope you can start to see as soon as I begin to fold this up that you are not going to get nowhere near as much volume in this box as you get in this box. So you might go, oh, well, then the smaller the square is, the more volume I get. But then I hope you can understand, and these are so small I've lost 3 of the 4, that if you cut out a square really tiny and you fold it up, this won't even hold its shape, but I fold this up, there's hardly any volume, right? So this is a classic kind of math problem where what we're eventually trying to do is maximize the volume. We want to come up with a maximum volume. And last year you did max problems in Math 20, but they all involved quadratic functions where you could find the coordinates of the vertex, which would correspond to a maximum. This is not going to be quadratic. So what's the first question say? Determine the polynomial function that describes the volume of the box in terms of the side length x that we use, and then use the function to find the side length that should be cut out to find the maximum volume. Well, this is a box, or, if you want to use math language, a rectangular prism. It's a box. And to find the volume of a box, you take the length times the width times the height. So this is the length. This is the width. And I guess this little bit of business here is the height. But we want volume in terms of x. Think about this for a second. When you take a look at the volume, I'll use this one because maybe it's a little more visual. When you take a look at the volume of this box, the volume of this is clearly, I hope you see it's different than the volume of this box. And the only change we made, this is an interesting idea, the only change we made is we used a different number for x, right? I cut out here x equals, 3 centimeters. And I cut out here x equals 8 centimeters. Or 4. It doesn't matter. But I cut out a different volume or a different length for x and got a different volume, which means, this is the interesting idea, the volume depends on x. I didn't change anything else. All I changed was x. So how are these things determined by x? I hope it's pretty clear here that the height is x. Right? And if you're watching this on video, unfortunately you can't see these boxes, but x is the distance between the tip of my thumb and the tip of my finger here. And when I fold this up, that becomes the height of the box. Right? And if you can visualize all of this in your head, that's great, but not a lot of people can, which is why I have this that we can look at. So x is clearly the height. Now, what is the length? Well, take a look at this diagram I have here where I told you that that's the bottom of the box. The length is this distance. It's from here to here. Well, the length of the piece of paper or metal or whatever it was before I started making my little cuts was 20. And I've removed x from the left and I've removed x from the right. So if this whole distance is 20, and this is x, and this is x, well, we don't need to make it complicated. You could say L plus 2x equals 20, and then say L equals 20 minus 2x. I think many of you, though, can just see it's 20 minus 2x, right? It's 20 minus x on each side. So the length is 20 minus 2x. The width is going to be 10 minus 2x for the same reason, that the width of the paper before I cut and fold is 10. I have to take off an x and an x. And then this is times the height, which is x. You are expected, everybody, to multiply this out. Okay? So if this were a multiple choice question, it could be that the answer looks like this or it's multiplied out. Let's multiply it out. Volume as a function of x. I'm going to FOIL out this stuff first and get 200. 20 times 10 is 200. My outer is negative 40x. My inner is negative 20x. My last is 4x squared. And then I can multiply everything by the x. So I'm going to get (4x cubed). I'm going to get negative 60x squared, because this gives me negative 60x, but I need to multiply by this other x, so it makes it negative 60x squared, plus the 200 times the x is this. We okay with that algebra? Ian?
How come we don't simplify the factors? 'Cause we can take
What is it you mean by simplify?
well, in 20 minus 2x, they have a full factor of 2.
So what you're asking is, why don't we factor the factors? Simplify means at this level to multiply things together. We're not taking it out because I'm asking you to write it in expanded form as opposed to factored form. If I wanted it in factored form, we would certainly take a 2 out of the first factor and a 2 out of the second factor and write 10 minus x, 5 minus x, 4x. Because if I factor a 2 out of each factor, I have a 2 times a 2 times the x, which is 4x. Okay. So that's the polynomial function. I have one more thing to add before we answer the question about how to get a maximum volume. If you walked into class and I said, here's a polynomial function, what's the domain and range? You would probably say, well, it's cubic, so the arms are in opposite directions, which means the range is any real number, goes up forever and down forever. And you would correctly say that a polynomial function is defined over all real numbers for x as well. Can somebody tell me why the domain of this function is not x is any real number? And if so, can you tell me what the domain is? And this is something you would be asked on an exam. Pardon?
Well, maybe it's because the box will have a maximum volume.
Kind of. So that if we said we know the box has a maximum volume, then that means that the volume can't be up to infinity. But I'm really wondering about x. I'm wondering about x here. Okay, so that's a start, right? So you would say, well, it can't be negative, so, oh, man. Can it be 0? Can I take this sheet of paper and cut out squares of length 0? I just did it. And make a box? No. So now you're down to the fact, if we're saying, well, it cannot be negative and it cannot be 0, then you're saying x is greater than 0. But you know what? That's not right either. X can't be any number bigger than 0. And I'm going to give you the diagram again. Marcel?
Can it be bigger than 20? Or 10?
If you said that, you changed it to 10, right? If you said we're getting there. If you said can't be bigger than 10, right? This would still be wrong. I'll give you guys a hint. The Ferris Bueller School of Teaching. Here's a hint. There's some number that we put here that makes this true, and there's no equals to on either of the inequalities. The number is not 10. Anyone? If you've ever seen Ferris Bueller's Day Off, that's how a teacher teaches. He gives a hint and then he says, anyone? Anyone? No? What's the distance between my fingertips on this in this question? 10. Can I cut out a square from both sides of length 8? No. Because if I cut out 8 from the left and 8 from the right, I won't have anything left. Do I? It's 5. You're limited here. It has to be a value of x more than 0, but less than 5. Because if I cut out 5, let's say I take that sheet of paper and I cut out 5 from both sides. It's going to look like that, isn't it? Because I will have removed 5 centimeters from the left and 5 centimeters from the right. There won't be anything left to fold up. And this is very important in how we solve this problem now. The only way you can find out the maximum volume here is to use your graphing calculator. If you take calculus with me, there's a very quick way to use the derivative of this function to find out this answer to the problem. And I might show it to you in calculus later today or maybe next week. So we're just going to graph this polynomial function. 4x cubed minus 60x squared plus 200x. Now, we're going to set up the window settings in a different manner. Well, we'll set them up the same way, but we're going to decide on the numbers differently. Go to your window settings. We already know we want to go from 0 to 5 for x. That's the only place this function makes sense. Now, hang on to your question. Now, we only want to go from 0 to 5 for x. That's what you were going to tell me, I'm sure. You only want to go from 0 to 5 for x. What do we want to go to for y? Well, volume can't be negative, so let's start at 0. How high up do we go? Here's where we're going to go to the table. And we're going to look in the table from 0 to 5 for x and see what the volume looks like in that region. So table set, start at 0 and go up by maybe 1. And you can see what the volume is. The volume goes up to 192, it starts dropping down, and it drops to 0 again. So let's put our maximum y to 200, 220, I don't know. I think 200 is sufficient. Just sufficient. Now you're going to find the coordinates of the maximum the same way you did last year with a parabola. You're going to go to your calculate menu, choose maximum, put your cursor to the left of the maximum, hit enter, put your cursor to the right of the maximum, hit enter, hit enter. So, the maximum volume is about 192 cubic centimeters. And that is the value of x that you need to cut out to get that maximum volume. So if you cut out squares out of this piece of paper or metal of 2.1 centimeters roughly, you'll get the maximum volume. And that's it. So went a little longer. I would have hoped to give you more time, but that's just the way the cookie crumbles sometimes, as my mom used to say. This is all about two things. One, can you use your graphing calculator to quickly factor a polynomial function? Can you cheat the system and go, I don't want to use a whole bunch of synthetic division? And the second thing is a couple of word problems that you might have to look at. So 1 to 5 on the following pages. By the way, on your handout, if you look at number 5, do I have a couple crossed out? Good. You do not know how to do those on your graphing calculator. Don't try to figure them out. If you're up for a challenge, you could. Anyway, I hope that makes sense. Did that go okay today? All right. I had mentioned that the quiz is Monday. Oh, we don't have school Monday. You don't have school Monday. The quiz is Tuesday.